Hello everyone, this is Dr. Sakti Mohanty. I am working as an associate professor in the Department of Physics in Gita Autonomous College, Bhubaneswar, Odisha. I have done a PhD in physics and my core area of research is photonics. But broader sense, my broad area of research is condensed matter physics. Basically, my identity is I am a physics teacher. I love physics. I am a physics enthusiast, I can say. And my post-graduation is with specialization of plasma physics. And I am basically teaching undergraduate students. I take lot of classes on physics and also on application parts like nanotechnology, like material science, optics, and I also love performing experiments with my students in the lab classes. My favorite experiment is related to optics, where I take my students to dark room and show them some very good, very excellent effects of light. And that is one of my favorite domains I work. And apart from that, I teach the engineering students beyond the classes, like clearing their doubts, talking to them beyond the syllabus, any question they have, any queries they have, I talk to them. And the beauty of my profession is that being a physics teacher, I always believe that physics happens to be an extension of life. It is connected more to life and it is something, a science like science of quest and science of doubts. And the best ever blessing I have come across a lot of very good teachers in my life. That is one thing I always take pride for myself. And today we'll be starting with the discussion of Compton effect, where we'll talk about the particle nature of light. Now let's begin the class with Compton effect. First, all of you know that Compton effect is about particle nature of light, and Compton effect is like a scattering phenomenon. It is a scattering phenomenon or it is a collision. Just like you can think of a 2D collision, two-dimensional collision. Imagine that you are playing carom and on the carom board you are playing your favorite shot, that is a cut shot. What do you do in carom? Your dot is here, the carom dot is here, and you are using the striker, this is the striker, and when you play the cut shot, the dot is scattered to one of the pockets of the corner and the striker is again scattered to another pocket of the corner. So, this is a little scattering effect related to Compton effect or Compton scattering. But what we do in Compton effect? We also have two particles colliding with each other, and these two particles are, one is electron and the other particle is photon. So, in Compton effect we are having this electron here and we are having X-ray photons coming from this and they collide, they strike. As a result, the electron is scattered, and look at this photon. This is the basic idea of Compton effect. We are having two wavelengths, one the previous wavelength lambda and we are having another new wavelength coming up, that is lambda dash. So, in Compton effect, electron is scattered by X-ray photons. As a result, we get two wavelengths, one lambda, that is called unmodified wavelength, and one is lambda dash, that is the modified wavelength. And this modified wavelength lambda dash is greater than lambda, and this difference lambda dash minus lambda delta lambda. This difference is called Compton shift. So, I repeat, in Compton effect, an electron is scattered by an X-ray photon. So, two wavelengths we get, one is unmodified wavelength lambda, one is the new wavelength modified wavelength lambda dash happens to be greater than lambda, and this difference lambda dash minus lambda is called Compton shift, and this whole scattering effect is called very famous Compton scattering. This shift is Compton shift and the whole scattering effect is called Compton effect. Now, the physics of this Compton effect is to look at the variation of Compton shift with the angle of scattering, and we will prove that the Compton shift increases with the angle of scattering. That is the job of this, and we have some graphical representation as well and some applications as well. Come back to this. We are having an electron which is stationary, static. You can compare it with the carom dot, and we are having an X-ray photon of wavelength lambda and frequency nu. You think of it as the striker of the carom board. You are striking this and the X-ray photons are striking the electron, and as a result there is a scattering. Look at the scattering. In this scattering, this way we are having a new wavelength lambda dash, frequency nu dash for this photon, and this electron or the dot is going to one of the corner pockets with a momentum p. Before collision the dot was at rest, so its momentum was 0. After collision, post collision, its momentum is p. Before collision the wavelength was lambda, frequency was nu for the photon, and after collision, post collision, the frequency is nu dash and the wavelength is lambda dash. So, looking at this particular idea, and we will discuss or we will suppress, we will forbid a bit of relativistic effects here, because we are not going to not much calculating the relativistic effect. We will ignore the relativistic effect or Einstein's theory of relativity. We will think of this collision as forbidding the effect. Now, think of this same picture is here. Now, we are having the electron scattered by the X-ray photons, and X-ray photons, we are having a new photon and that wavelength is lambda, new wavelength lambda dash, and the difference is Compton shift. Now, we will apply this particular two laws, two conservation principles. All of you are very acquainted with conservation of linear momentum and conservation of energy. So, let us find out some aspects of some parameters before collision and after collision for these two particles involved in this scattering or collision process. Come to this. Before collision, after collision, go to energy of photon before collision. Energy of photon before collision is h nu, because all of you know Planck's quantum theory, energy of light is h nu. And after collision we are having the new frequency nu dash. So, post collision the energy of photon is h nu dash. Momentum of photon before collision h nu by c, when energy is h nu upon c is the momentum, and after collision the momentum is h nu dash by c for the photon. Now, let us find out the same parameters for the electron. Energy of electron is m c square, but I am writing here as m 0 c square. What is m 0? M 0 is called the rest mass of the electron, and after collision this is a striking feature you have. The energy of the electron after collision is m c square. So, carefully mark, there is a change in mass. So, we are implementing or according to Einstein's theory of relativity, mass is also a changing factor when the objects are traveling with much high velocity. So, due to that high velocity, there is a change in mass. So, we distinguish these two. This is m0, the rest mass of the electron. Before collision, the electron was at rest, and after collision, the electron is moving with a greater velocity. Atomic and subatomic particles, mass is very less, and change in mass is evident. So, this m is a changing mass, and we call it as the relativistic mass of the electron. Momentum of electron, as I told, it is 0 before collision because it was at rest, and after collision it is scattered with a linear momentum of p. So, now we will be applying two conservation principles, conservation of energy and conservation of linear momentum. If we apply conservation of energy principle, by applying conservation of energy, energy before collision, energy of photon is h nu, energy of electron is m naught c square. So, energy before collision is h nu plus m 0 c square, and after collision energy is h nu dash, and the energy of the electron is m c square. So, it is h nu dash plus m c square. So, this is written according to law of conservation of energy. Total energy before collision is equal to total energy after collision. So, that is one of the equations from this particular table. Now, let us apply law of conservation of linear momentum before collision. But one important thing about momentum, energy we can add as numbers because energy is a scalar quantity. But when you think of taking care of momentum, you have to think of the vector addition. So, here this is the momentum, and imagine two mutually perpendicular axes to find out the rectangular coordinates. If this is the momentum, this component is p cos phi, this component of momentum is p sin phi. This momentum is h nu dash by c. So, this component is h nu dash by c cos theta, it is attached to the angle cosine. So, here this is h nu dash by c sin theta. So, when you think of adding the momentum, linear momentum before collision and after collision, you have to think of two axes, one x axis coordinate, one is y axis coordinate. So, look at the before collision the momentum of photon is h nu by c plus 0, because along x axis the electron was at rest before collision. So, the momentum is 0 is equal to, now think of the x axis coordinates of momentum of electron and photon. So, this is p cos phi and h nu dash by c cos theta. So, we get h nu dash by c cos theta p cos phi. So, that x axis component is over. Now, come to adding the y axis components before collision and after collision. Carefully mark, before collision the photon was travelling along x axis only and the electron was at rest. So, this vertical component or y axis component of momentum before collision is 0 for both, and after collision it is h nu dash by c sin theta p sin phi. But look at this, h nu dash by c sin theta is up, vertically up, p sin phi is vertically down, negative x axis, one is positive x axis. So, this is minus. So, this minus this. So, these three equations are now established looking at the parameters before collision and the parameters after collision by applying two conservation principles. One is conservation of linear momentum and other is conservation of energy. So, these three equations we establish, and without thinking much, without using much mathematical solutions, we just directly write down the results. So, by solving these three equations, no need to solve it now, by just solving these equations we get lambda dash minus lambda. We get lambda dash minus lambda is equal to h by m0 c 1 minus cos theta. This is one of the important conclusions driven by solving these three equations. So, here we get this. This is more significant now. We are focusing on this lambda dash minus lambda is our delta lambda. So, the same thing is going on, taking care of conservation of momentum and conservation of energy. Now, this delta lambda is h by m0 c 1 minus cos theta. So, now we come back to this is our Compton shift. This Compton shift, that was the target at the beginning. This is the relationship of Compton shift with the angle of scattering theta. We want to know this variation. How does it depend on, how does Compton shift depend on angle of scattering? Delta lambda is h by m0 c, that becomes a constant. H you know Planck's constant, m0 is the rest mass of electron, c is the speed of light. We take it another constant lambda c 1 minus cos theta. This lambda c is h by m0 c, that is 0.0242 angstrom units, and this has a name called Compton wavelength. This is Compton wavelength. So, it has a value, fixed value. So, this is the result on which we are focusing on. So, Compton shift is lambda c 1 minus cos theta. Now, look at the variation. Theta, if I increase the value of theta, cos theta will decrease, all of you know that very much. Increasing the angle, cos theta decreases. So, 1 minus cos theta, this result 1 minus a small quantity becomes a greater quantity. So, I repeat, by increasing theta, cos theta decreases, 1 minus this small quantity leads to a greater quantity. So, look at this increase in Compton shift with increase in angle, look at this. So, there is an increase in theta and there is an increase in wavelength or Compton shift. So, this is the relationship between these two. So, our Compton shift increases with increase in angle of scattering. Now, about my works. Apart from my classroom teaching or academics, I am also involved with research and development in our campus. And as my own research, my research belongs to photonics and basically photonic crystals, and these have been there as the use of telecommunication and sensing purpose. And one of my major works involves the designing of 3D photonic crystals for the detection of breast tumor cells, and that though I am a theoretical physicist, still if it has been implemented into experiments, though 3D photonics are now difficult things to manufacture, but in recent future had it been successful, then we can quickly detect the cancer cells, basically breast tumor cells, whether they are cancerous or they are non-cancerous. And one of my other works involves using photonic crystal structures for communication purpose, so that we can filter out some of the wavelengths from the light which is falling on that photonic crystal. We can have different windows, and all these windows can be filtered out, and the required window of light, a particular wavelength of light, can be utilized for this communication purpose. And also some of my works are there starting from 1D, 2D and 3D photonic crystals. One 2D photonic crystal is there for sensing, basically temperature sensing. These are some of my research works I have done and I am also working on. Then about my work, what else I do, I take few groups of students, my own students from our college, and I guide them or I motivate them for the research works. They publish small papers. I also motivate them for some sort of science exhibitions. And about my other works, I can claim that I am a very popular science communicator. I visit some of the schools to take the students into the journey of science. And my intention is to familiarize the students or the young minds much more to science and basically physics, learning physics and putting an interest in this particular thing. And these are the things I am involved with apart from teaching and research. I also do some TV programs where I take popular science discussions with many panelists, and that is the work I am used to connect. Now to note down some of my achievements, I would like to share that being a teacher and being into research, I also take up some projects work with my students, and I co-authored a couple of books. One is Engineering Physics 1 and Engineering Physics 2. And my co-author for these two books is Professor Randhir Singh from PTU, Punjab Technical University. And regarding other achievements, I write poetry and short stories as well. I had that national scholarship. I was a winner of national scholarship. I love playing volleyball. And one of the best thing I love is to take my classes, to be with my students, because during my classroom teaching I also learn a lot from my students, from their questions, from their quests, and sometimes I fail to answer their queries, but I try to learn it so that later on I can talk to them or I can clear their doubts. And about my other achievements, I try to publish my papers in good journals, and so that I can connect to research, and I take up some courses, basically professional courses from Coursera and from AICT, Atal programs. And recently, for last couple of years, I have taken universal human value courses that makes me as physics, connects us to life. This UHV connects me more to humanity, to put humanity in our life, and it is like a self-development course, and I also take these classes apart from other things, and also I teach professional ethics sometimes or research ethics sometimes to my students. And this UHB I have done refresher 1 and refresser 2 still courses, and now I am a resource person in UHB. And some of the universities, they also invite me to talk to their students in different lectures. They provide me some platforms, and these are things I think I have achieved apart from my teaching profession. The best ever thing I am proud of is being a physics teacher, and I connect, and that gives me a freedom of connecting young minds, basically connecting to young bloods in many ways, so that I can improvise myself through this physics teaching. And another important thing of physics and science, I always find, and I connect to students, I talk to them, like it makes me distinguish between superstitions and beliefs. Mostly to free our society from superstitions, which is still practiced in many of the communities and in many of the society, irrespective of money and irrespective of power, irrespective of book learnings. And science will take us away from superstitions, and physics will shape us to be a little better and little better human being. Thank you.